Good day, viewers and class. Welcome to Easy Learning Tutorial Class WAEC Physics Question and Answer. You are welcome. Remember to subscribe to this channel and remember to love the channel and share to your friends. Look at what I have for you today. This is a WAEC question on 2012 to 2013 on optics. This is a question on optics. He said, explain the term critical angle, and the mark is 2 marks. List 2 factors which determine the deviation of a ray of light by a triangular glass prism, 2 mark. The angle of refraction R of a ray of white light from air through a triangular glass prism of refractive index 1.5 is 29 degrees. Calculate the angle through which the ray least deviated. D. Study the ray. This is 4 mark. It says study the ray diagram below. Use it to answer the question that follows. He said, look at the diagram below. Look at the diagram. Can you view the diagram properly? It said calculate value of angle PQR, then II, refractive index N of the glass prism, III, value of E, IV, total deviation, and it carries 7 marks. Total of these marks is 15 marks. Total of these marks is 15 marks. In WAEC physics question, you are required to answer 5 questions in part A, theory, and another 4 questions from part B, theory. That 4 questions from part B, theory each carries 15 marks, note it. While in section A, each carries 8 marks. 8 marks times 5 give you 40, while 15 marks times 4 will give you 60. Giving you a total of 100 mark. So if I'm to advise you, I said, if I give you a question in physics, you first go to question part B, which we are answering now. Look at this question comes from part B. You go to it. If you be able to answer 3 questions from there, go to part A, answer 3 questions. You are good to go to have your B. So then let's go to the answer of this question. Answer of this question, we say solution. They say that critical angle is the angle of incidence in the denser medium when the angle of refraction in the less dense, medium is 90. What are we talking about? This implies that for me to get critical angle, my ray must be moving from denser medium to less dense. Before I begin to talk about critical angle, that means my ray must be moving from denser medium to the less dense. Just look at this. Look at this. Let's see what I mean by that. I have this. This is glass. This is glass. This is glass. Then my ray move from this glass, strike this place. And I will have to draw my normal. Look at my normal. And this is the angle of incidence. This ray will move this way. This is the ray out, this is the ray in, and this is what? Angle of refraction. If I increase this man, watch here. If I increase this angle, what will happen? Can somebody tell me what will happen over there? If I increase this angle, look at this ray, I increase it to increase the angle, what will happen? This man will deviate more away from the what? The normal. You know that this man goes out to the what? Less dense, which we'll call air. I call this place air. This is air. This is glass. That means this ray is coming from glass, going into what? The air. As I increase this angle, what will happen to this man? He moved more away from the normal. Look at this line I draw is normal. If you remember, this is normal. You move away from the normal. So the more I increase this man keeping moving away from the normal. So assuming now at this point, watch this diagram here now. At this point, I increase this man. At this point, I increase this man to have this as my normal, and this man move straight this way, making an angle of 90 here, which is angle of refraction, which is equals to what? R, refraction. This angle here, which is my incident angle, will turn to be called, is going to be called critical angle. This C stands for what? Critical angle. At the point where I have increased this ray and the angle of refraction in a less dense medium become what? 90. Automatically, the angle I have here as my incident angle turn to be what? Critical angle. Can somebody understand what I'm talking about? Then now, and this 90 become my angle of refraction. Then, you remember our Snake's law, which said that what? Glass to air, because I'm going from glass, entering air. That means this is the refractive index of what? Air. This what I wrote now here is a refractive index of what? Air. Because I'm already in glass, that the ray is already in glass, entering the air. That means glass to air. And then who is one of the refractive index? Air. Just like today, I have known today as Monday. Then tomorrow is what I'm thinking about how it will look like. So if I'm now today, which is Monday, I'm now looking at what? Tomorrow, which is what? The refractive index of tomorrow. I'm no more looking at today because I'm already in today, which is Monday. So that's what I mean. This man is in glass, heading toward air. Therefore, the refractive index we are looking for is what is going to experience in air. He's already know what is passing through in glass. What am I going to pass through in air? That was what we call refractive index of what? Air. And this is equal to sine of what? Ah, okay, let me clean it here properly. Let me clean it here so that on this place I will have what? Glass to air equals to what? Sine of what? Incident over sine of refraction. That's next law. Incident angle over what? Refraction, right? Then coming over here, I will have also glass to air to be equals to sine of what again now? C. Instead of what? I become what? C over sine of what? 90. What is refraction now? Is 90. Are you not saying that? R now here is what? 90. Therefore, I cannot say sine of 90 will give me glass to air is equals to sine C. And you remember, what is C? C is a critical angle. C implies what? Critical what? Angle. Critical angle, which we are defining. You get what I'm saying? You have seen where our definition comes from. That what? A ray passing what? Is angle made of incidence through what? A denser medium to less dense. So now, this is what I have as a what? Critical angle. But remember, can you remember? That what I have in my diary is a what? Refractive index of air, glass and water. That means what we have is what? Air to glass refractive index, which is 1.5 or 3/2. Another one I have is what? Air to water, which means refractive index of water, which is equals to what? 1.33 or 4/3. This is the two refractive index I have. Any other thing that doesn't revolve on this, I have to resolve them to be in this form. These only two refractive index will have. in our diary. So if any man fall out of this man, I have to resolve that person to come in form of this man which I know. Then now let's move to this place. Did I know this man? No. But I know that 1 over air to glass is equals to what? Glass to air. And this is what we call reversibility of lights. We call it what? Reversibility of light. A light can go into air or go in from what? Glass to air. This light can go from glass to air and also go from air to glass. That's what we call reversibility. That it can come out from glass to air or from air to glass. So look at it now. So I can use this man now here to replace this matrix. I think you are getting what I'm talking about. So when I use it to replace, when I use it to replace, let me write it here for us to see space. If I use it to replace, I will have 1 over air to glass, which I have in my diary, is equals to sine of critical angle. Look at the formula of critical angle. Are you not saying that? You remember what we did? From here, we say glass to air gives me this. Are you not saying? But this man, glass to air, I don't have it in my diary. But I know that 1 over air to glass, which I have in my diary, is equals to this man. So, and I use this to replace this man in this equation and return to this. And I know this man, air to glass, as what? 1.5 or 3.5. If I put it here, I can make this man subject to formula and get the word, the critical angle. I think we settled, right? Good. Then this is how we get critical angle. Then somebody will ask, what if we continue to increase this man more and more? If we continue to increase this man more and more, what we are going to achieve is what we call total internal reflection. If I increase this more and more, as I've achieved getting what critical angle and I continue to increase this angle, what will happen? This ray will continue going in. What we see now, this man will go in, it will continue. As I increase it, it will go like this. Increase it, it will go like this. And as I increase it more, it will go like this. And this is what we call total internal reflection. That means the reflection is in the same medium. Both the incident and reflection is in the same medium. That's what we mean by total internal reflection. And this will only occur in a denser medium. When I'm moving from denser, when a ray is moving from denser medium to less dense, that's where we can be able to achieve what we call total internal reflection. We can also, that implies to me that total internal reflection occur in only one medium. What do you mean? Look at it in the glass. Look at the glass here. The incident is in the glass. Reflection is in the glass. We said is in one medium. While refraction, have you seen the difference between the reflection? While refraction will occur in two medium. So that's not what they asked of me. I'm just giving you to know that I will achieve total internal reflection in a moving from denser medium to less dense. Can I claim this? So that we'll go to what we have. Then we go to the next question. What's the next question? The next question was asked that which what links the two factors which determine the deviation of a ray of light by a triangular glass prism. That's true, Mark. We should list the factor. We see the factor is a simple thing. The angle of incidence. The factors that affect deviation of ray are, number one, angle of incidence. The more I increase the angle of incidence, the more the what determine the what the deviation will continue to what increase, either increase or decrease. I get what I'm saying. So as I increase the incident angle, deviation will also increase or decrease. Depends on the medium where I'm coming out. If I'm coming out from what? If I'm coming out from denser medium going to less dense, you'll see that my what deviation will increase. I will move away from what normal. But if I'm going from air to what to denser medium, that means I'm coming out from less dense medium, going into denser medium, what will happen? I will go close to, the ray will go close to normal. What I mean, watch what we are talking about. I have this, look at air here, look at air, and I'm moving from air, entering this is a glass. So for you to get it, there is a glass, I have a normal like this. This man, as I enter this, I have entered denser medium. What will happen? I will come closer to what? The ray will come closer to what? Glass. To the normal. Look at my normal. It will come closer to normal. I just said it. It will come to closer to what? Normal, because I'm from what? Less dense entering the what? Denser medium. Then what of if it this way that I have a glass here, moving from this glass, entering the air, I have my normal, entering the air, look at my normal, what will happen? You will see that I will move away, the ray will move away from the what? The normal. You see that this will move away from the normal, and this is my angle of incidence, this is my angle of refraction. You see it will move away from the what? Normal, because it will run more faster. So you now see that this incident angle affects the what? The deviation of what? Ray. Then let us go to the second answer there. The second answer was saying refracting angle of the prism. Refracting angle of the prism. What we call refracting angle of the prism. If this is a prism, look at my prism, and this angle, which A, this angle, B, this angle, what, C, is what we call refracting angle of what? Prism. Basically, let me use A. So if this A is big, that means this triangular prism will be more wide. If it is what? Small. If this angle is small, you see that this triangular prism will be this way. You see that for me to pass through this place and for me to pass through this place is different. So if when I have here to be what? Maybe 30, and I have here to be what? 60. You see that the what? The distance I will pass is more on this place than this place. We will say that's what we call what? Refracting angle of the what? Prism. So you see that the more, if this man is less, the ray will deviate less. If this man is big, the ray will deviate what? Much. So we said the refractive angle of the prism. I think you have understood it. Then the next one, the third one, because they asked us 2, but we are presenting 3 here, so that you choose anyone. Then the third one is refracting index of the material of the prism. Refracting index of the material of the prism. This is the ability of the prism to what? To deviate, to pierce easily. This is how thick the prism is. This refractive index determines what we call the thickness, the ability of ray. That one means, let me put it, the thickness of the prism. How thick, how compacted the prism is. That's what we call refractive index of the prism. So if ray pass through this prism easily, you say that the prism is what? Refractive index are less. So that one means you see that refractive index of this man will be less than refractive index of this. Refractive index of this prism will be less than this man. So the more the refractive angle of the prism, the more it what? Refractive index. So I think you have settled it. The more the refractive angle of the prism, the more its refractive index. You see the difference between 2 of them. As this man is increasing, this man is also increasing. As this man is decreasing, this man is also what? Decreasing. So I think I've made it clear to you. So note it today about the prism. So let's go to this third question, which is called D. Let us go to the C question. What is our C question? Our C question said the angle of refraction. Our C question said the angle of refraction R of a ray of white light from air through a triangular glass prism of refractive index is this. Look at the triangular prism, look at this refractive index, and it's what? 29. They said calculate the angle through which the ray is at least deviated. So let us look at this. You remember what we have proved in our former physics, WAEC physics. That's the question I proved the laws. So if you are not going through that proof, go, because if you have not studied that proof, that means you are lacking on optics. You know that this question is optics. So you needed to study that proof. Then let us move. Look at this. I will say question C. I will use n equals to what? Sine dim, which we call minimum deviation, plus what? A divided by 2 all over sine of A divided by 2. This formula was proved. Go and study this formula proved in our physics WAEC question, physics and answer. There's a physics WAEC physics question and answer. Study it. We have done it. If you study it, this question will be as, in fact, my mind to it. This question will be my mind to you. You will understand the question very, very well. So look at it. Then what did they give me? This man here is called refracting angle of prism. Refracting angle of the prism, which is given to me. Look at it. The refracting angle of the prism is what they give to me is what? Refraction. I need to say this man is refractive angle of the prism, while this man is the refraction. So I can now move. Can we move ahead? I will not say, but looking at this, what they give me is 1.5 as refractive index of the prism. Okay, let me put it clear here. 1.5 and is equals to sine of what? Dim plus what? A all over what? 2 divided by what? Sine of A over 2. You remember? Look at where I get 1.5. They say refractive index of this man is 1.5. Look at there, over there, right? This man is a what? Refraction. So refraction, which they said, and I remember that A is equals to 2 times refraction. Where did I get this? From that proof. Go there and study it. I said if you study the proof of this particular man, he will what? Take this question as my mind. Then this will be equals to 2 times what? 29. Where did I get 29? Look at it. They say refraction of a ray, white light from the air through a triangular prism is given as what? This 29 degree. So this man will give me what? 58 degree. This will give me 58 degree. That means I've gotten my A to the what? 58 degree. Putting it over there, I will have 1.5 equals to what? Sine into what? Dim. This is dim plus what? 58. All over 58 divided by 2. Are you following? All over sine. What will happen here? This is A, which is 58, divided by 2 will give me 29. Are you getting what I'm saying? I think you understood me. Look at A, 58, divided by 2. Look at 58 divided by 2, give me 29. This one is here. So can I continue here? I can clean here to continue. Have you noted this? Yes, you have noted it. Let's go on this place so that we'll follow here to finish it. So now, let's see what's exactly what we have. We have this to the 1.5 over 1. You remember that anything I write is divided by 1 and the answer is that thing. So is equals to sine of what? The dim plus 58 all over dim plus 58 divided by 2 all over the sine of what? 29. Right now I can do cross multiplication, you know. Right now this is a fraction, this is a fraction. This man over here, this man over here. I will have that what? Sine of dim plus what? 58 divided by 2. Sine of dim and 58 divided by 2, because 1 times all of this will give me this, is equals to 1.5 times sine of what? 29. And this will give me that sine of what? Dim. Sine of dim. minimum deviation plus 58 all over 2 is equals to, if you multiply that, this, then it will give you 0.7. This will give you this. If you have this, you have 1.5 because YX is necessary. Marking this, you have to put it 0.4848, and that's, if you multiply this give me this is this, multiply this, it will give you 0.7272. So when we got that, I don't know whether you have noted this. Have you noted where we started? You noted that? Then I can claim them now so that we can be able to move ahead. You just note them to move ahead. So when we multiply that, I have now sine of what? Dim plus 58 all over 2 divided by, equals to what? 0.7272, right? Then right now, this angle, look at its fraction. You know that all this place is angle. Somebody will be confused. Look at this. If I write sine theta, this theta now have turned to theta now is what? T dim plus what? 58 over 2. Look at what the theta turned to. This man, I know him as an angle. Whatever he turned to doesn't concern me. So whatever that is here, I know it as what? An angle. Because this theta is what? An angle. I think nobody is confused about that. So I can now simply say that what? This man, dim plus 58 all over 2 is equals to sine inverse. Let me clean over here. Sine inverse of what? 0.7272. Understood? Yeah. How? Look at, if I say sine theta is equals to 0.7272, what do you do to get theta? You say theta is equals to sine inverse of what? 0.7272 is what we normally do, and that's the same thing you are doing here. As I told you that this is still the theta you are talking about. So you do normal thing you know how to do. So no matter how they wanted to confuse you, you do normal thing you know how to do. So now, can we now find the sine inverse? I'm claiming here. Can we now find the sine inverse? If I find the sine inverse, I'll see that this dim plus 58 divided by 2 is equals to sine inverse of that man will give me, what is going to give me 93.3. Therefore, this is over 1. I think you know. This man give me this. Over 1 is same this man. Cross multiplication. I can now say that dim plus what? 58 is equals to what? 2 times what? 93.3. And that will give me, what is going to give me, when we do this angle, it will give us, angle of this will give me 46.65. That's what the angle will give me. To find sine inverse of this, use your calculator to find that. It will give you this. So this man will turn to be what? 46.65 times 2 will give me 93.3. That's what it gave me. Then now, since it gave me that, and I will have that my dim, making it subject of formula, I will have that is equals to 93.3 minus 58, and that give me my dim, which they asked me minimum deviation. This look at it. What they said here is what? Least. What they say? Least deviation. Least deviation is also interpreted as what? Minimum deviation. You know why? They know how to use grammar to confuse students. Least deviation means minimum deviation. Look at what this thing I'm writing here, what it implies what? Minimum deviation. Minimum deviation. Or we'll call it what? Least deviation. Least what? Deviation. Note it. This means what? Minimum deviation or least. Minimum means what? Least deviation. I think you have got it in that. So this man minus this will leave me with what? 35.3 degree. That's the answer of the question they asked us. They say we should find the what? The least deviation, and that's what we call minimum deviation. Least deviation is something as minimum deviation. Have you noted it? I think you have understood it there, so that if WAEC wanted to confuse you, they put least deviation, know that we are talking about this man. If they said minimum deviation, know that we are talking about this man. Then, right now, we are through with our question number C. Now, let's go to question number D. Question number D. Can you note this? Can you note them? Have you noted them? Yeah, I believe you have noted them or paused them. Okay, now, let me click here and do question number C, so that we follow up, so that we can be able to challenge WAEC in his question and his grammar. So look at this. Look at this. This is where the proof we made in that formula we use. The proof of that formula is where this thing lies. That's why I say look for that video where we do the proof and I explain it in detail. And I told you that's where WAEC will be hammering you question to know whether have you studied that proof. Then coming to this, if you have studied the proof, you see that at a glance you'll be just telling the answer of this. If you have studied the proof, at a glance, if you just watch this, you tell them the answer, you write the answer. Watch it. If I look at this now, I can say 45 degree equals to what? P plus 20. What's the reason? Vertical opposite angle. Automatically. I cannot say that what? P, I'm answering question number D now. D now, I can say I, D, I, right? I cannot say that what? P plus 20 is equals to 45 degree. Therefore, I cannot say this implies, so that space, this implies that what? P is equals to 45 minus 20 and is equals to what? 25 degree. I've gotten my what? My P, which they say I should find. Look at here. Here is what? P. They say I should find P. Then I'm looking for Q. What's the Q? I cannot say, look at the Q. Watch. At a glance, watch Q. This Q plus what? 60 is equals to what? 180. Angle on a straight line. I cannot say that what? Q plus what? 60 is equals to 180. Are you get what I'm saying now? What's the reason? You have to state the reason. You have to state the reason. What's the reason? Why did I say that? I will say what? Angles on a straight line. Are you get what I'm saying now? This man, why did I say this plus this? You remember, look at the reason. The reason is what? Vertical opposites. I'll just put dot here, means opposite what? Angle. This stands for what? Angle are what? Equal. Vertical opposite angle are equal. That's the reason of what we said here. That's where I put the reason. Are you following me? That's the reason, because you have to state the reason. As I said, this plus this equals to this. You have to state what? The reason for you to collect your full mark. If you didn't put the reason why you said it, that means you are imagining it. So the reason, who said that? Because you are not the one saying it. Who said that is what? Vertical opposite angle is the one that said that this is equals to this. So if you state it without stating who said that, WAEC will give you half mark, or even not to give you at all. So if you state anything in a word geometric, you have to state the reason. So I say Q plus 60 is equals to 180. Reason why I say that, angles on a straight line. Therefore, I can say that Q is equals to 180 minus 60, and Q is equals to what? 120 degree. That's answer for this one. Then I have gotten my Q. R. They say, what is R? As you get the R. I can simply say that R here, I can get the R by saying that what? Either I say P plus what? R is equals to 60. What's the reason? Who said this? Who said this? I will say what? Exterior angles, let me write the angle in word, angle equals to Sum of two, sum of two, sum of two opposite interior angles of a triangle. Look at what I'm talking about. Listen, look at what I'm saying. If you have a triangle this way, I have that this angle here is equals to this plus what? This. That means if I have theta here, watch me. If I have theta here, this theta is equals to A plus B. Exterior angle equals to sum of the what? Opposite. Sum of the what? Interior opposite angle. Look at it. That's what I mean here. Watch here. This man is equals to this plus this. It's a triangle. Or I would have said I have my P. I've gotten my P to be what? 25. You know that we have gotten P to be 25. This gives me 60. Then I will say R is equals to 60 minus what? 25. And that gives me what? 35. That's my R. Or if someone cannot remember this, I can come over here and say this angle plus this angle plus this angle will give me what? 180. Sum of angle in a triangle. I cannot say P. I said or. You can use this way P plus what? R plus what? Q is equals to what? 180 degree. Reason. What's the reason? What's the reason? You said what? Sum of what? Angles in a what? Triangle. I cannot say that what is my P is 25. What is my what? Q. My Q, I have gotten it before, which is what? 120. I think you are following me. Is equals to 180 degree. I can say that 25 plus 120 will give me what? R plus what? 145 is equals to 180 degree. I can say R is equals to 180 minus 145, and that will give me what? This will give me R is equals to 35. Is not the same answer? I got on this, I got on this. So any of them can go. If this one you remember, you use. If this one you remember, you use. I've given you the two ways which you can use to get your R. What's the next question? The next question said, I said, refractive index N of the glass prism. Refractive index N of the glass prism. We now said that I'm going to I've answered the question of I. We now say refractive index of glass prism said N is equals to sine of what? Incident angle over sine of what? Refraction. And in this case, what's the refraction? Sine of what? Incident 45. What's my refraction? My refraction is P. Look at it. My refraction is what? Angle P. And what is angle P here? I have gotten my P to what? 25. I think you are following. This angle of incident angle over sine of what? P, which is my what? Refraction angle. P now represents refraction angle. Look at P is a refraction angle. And this will give me sine of 45. Sine of 45 will give me 0.7071 all over. Sine of this will give me 0.4226. Therefore, this will give me 1.67. Therefore, my refractive angle will be 1.67 as my what? Answer. What again? The last question, the second to the last question says calculate E. We say we should calculate what? E. Looking over here, can you come over here and watch what I'm doing? Look at it. Calculate E. I can calculate this E by saying that this man, this angle plus this angle is equals to E. Can somebody understand what I'm talking about? This angle plus this angle is equals to E. Are you getting carefully what I'm saying now? This angle plus this angle is equals to E. Or I can calculate E using my what? Formula, which says that what? Again, can I clean up here? I can calculate E. Let me just clean here. Let me clean here. Can we move ahead and say what? I, which said what? E. I'm looking for E. I cannot say N is equals to sine of what? E over sine of what? R. Are you following what I'm doing? Sine of E incident over refraction. This over refraction. And I will say this is 1.67 over 1 is equals to sine of what? E over sine of R. What is my R? I have gotten my R to be what? 35, which is 35. I get what I'm saying now. So this implies if I do cross multiplication, I will have that my what? Sine E is equals to 1.67 times sine of what? 35. That implies that my cross multiplication, it implies that my sine E is equals to this times this. Therefore, we have sine E is equals to, if you have that, if you have 1.67 times sine of 35, let me look at that sine of 35, I haven't done that. I have what? 0.5736. 0.5736. Then if I do that, I will have that what? Sine E is equals to, if you multiply that, it will give you 0.9579. Therefore, E is equals to sine inverse of 0.9579. Therefore, E is equals to 73.3 degree. That's my E. 73.3 what? Degree. Then what again did they say I should find? They say I should find deviation. The what? The total what? Deviation. I'm cleaning here now. Let's find the total deviation. This question said total deviation. What's total deviation? D. And I say I can get this plus this is equals to E. I cannot say that what? If I call this place maybe X, I get what I'm saying? If I call this place what? X, this plus this will give me E. X plus what? R is equals to what? E. You remember what I said? If I call this angle here, this angle X, this means X plus this angle now X plus this is equals to E. The reason, what's the reason? Vertical opposite angle. The reason is vertical what? Vertical opposite angles are equal. And I'll say that X plus what? R. What is R? I got my R as what? 35, right? R equals to my E is what? 73.3. Therefore, I can now say that my X is equals to 73.3 minus 35. Are you following? 73.3 minus 35. And what is it going to give me? If I now subtract this minus this, if I minus 35 from here, it will give me 35. This is 73, 35. This goes 13.7. This 8 and 6, 3. 38.3. This will give me X is equals to 38.3 equals to 38.3. That's what this man will what give me. Then as he gave me this, it's 38.3. Am I correct? Am I correct? That will give me what this? Can I move that? This 35 minus this, yeah, so give me that 38.3, I'm correct? 38.3, that's the one, because I don't have calculator yet, I'm using my brain. It's 38.3. So now, coming back to the, I've gotten this, I cannot say that this plus this will give me D. I cannot say that D is equals to what? X plus 20, and that will give me equals to D is equals to, what's my X? 38.3 plus 20, and that will give me, that this man will be what? Will give me equals to D is equals to what? 58.3 degree. That's my answer for what? D. Then if they now ask me, I can use the formula which we have proved that D, minimum deviation, is equals to I plus what? E minus what? A. This is another formula I can use. that D is equals to I plus what? E minus A. Then go to that proof, you will understand what I'm saying. You can use this formula, and I will say D is equals to, what's my I? 45. What's my E? My E is what? 73.3. And what is my A? My A, which I have what? 58. 58 is my what? A. What is my A? I think, look at the A. Sorry, I'm not getting it right here. Look at A here. 60. A is what? 60. And I can say that what? This will give me 58.3 degree as my answer. This is angle. A is a what? Refracting angle of the prism. What they give me as refracting angle of the prism? 60. So they gave it to you here, refracting angle of the prism. So if you use this formula, you have gotten the I is given to me. E is what? Calculated. A is already in the what? Diagram. I add this plus this, subtract from 60, it will give me, if you add this plus this, subtract 60 from it, it will give you this as what? The deviation, total deviation. This is different from minimum deviation. This is total deviation, not minimum deviation. At minimum deviation, you will see it in that proof of that formula when I was differentiating it. Total deviation, deviation and minimum deviation. Note it. Go to that video and study this proof, and you will understand this properly. Thank you for watching this video. Thank you for commenting. Remember to subscribe. Subscribe in this video. Subscribe. Subscription is free. Subscribe and comment. Share to your friends. Let your friends know of what is happening in this YA question and answer on physics channel. Thank you, and see you in next video.